Okay, guys, so those of you that have come here, you need a little bit more help in terms of stratigraphy and index fossils. So I'm going to break it down into two parts. So the first part is stratigraphy. And basically, there's four principles that you really need to remember and be aware of. And the first thing is that stratigraphy is all about dating rocks from one place compared to another place, from layers of rocks compared to one another. So the bottom layers here are going to be your oldest layers, and the top layers here are going to be your youngest layers. Sedimentary layers are created flat, just like a cake, and each layer takes hundreds to thousands to even millions of years to form. Fossils can be found in sedimentary rocks, but it requires very particular circumstances for them to survive the millions and millions of years. So, as a result, we don't have that many fossils, but we do have enough to piece together the history of the Earth. So, these are the four basic things that you really need to remember. Number one is this thing called the law of original horizontality. What that means is every single rock, when it was created, was laid down flat and horizontal, just like this. If rocks happen to be tilted, or if there happens to be a fault where rocks have shifted and they're no longer aligned and matched up with one another, then that indicates that that happened after those rocks were formed. So, that's your clue. Faults come after those rocks were made. The law of superposition is really straightforward. It says that the oldest rocks are found at the bottom and the youngest rocks are found at the top. That's just, it just makes sense. You cannot have a bottom layer without, or you cannot have a top layer without having a bottom layer. Just like you can't have the top layer of a cake without having the bottom layer down first. So you have to have that foundation, and everything else gets built on top of that. The next one is the law of cross-cutting relationships. So what it means is if there is something that cuts across other layers, then it is automatically younger than all the layers that it cuts across. So what happens here is there's magma that comes up from the interior of the Earth. It melts or erodes or dissolves the rock that it's cutting through because it's so hot, and it cools and it forms a new layer that goes diagonal, or it goes straight up and down instead of horizontally. So anything that is not laid down horizontally that happens to cut through many layers, it is automatically younger than the layers that it cuts across, because layers 1, 2, and 3 had to be there in order for layer 4 to come and erode or melt or dissolve those layers and then harden into its own layer. So the order goes 1, 2, 3, 4, and then 5. 4 is younger than 5 because 4 did not cut into layer 5. Magma will continue up to the surface just because it's less dense. So if it stops at this layer, that means that this layer did not exist before the magma rose up and cut through it. So the magma will cut through all of the layers that it goes through. So that's just how you want to think about the law of cross-cutting relationships. The last one is inclusions. So inclusions are bits and pieces of rock that are included in other layers of rock. So that means that these bits and pieces of rock are older than the layer of rock that they're in. So just think about chocolate chip cookies, which I just baked some this past weekend. So chocolate chips are way older than the cookies or the batter that you are making. You go to the store, you buy those chocolate chips. They were made a long, 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 long time ago. And then you make your cookie dough, and then you pour the chocolate chip cookies in, or the chocolate chips into your cookie dough. So those chocolate chips are automatically older than the batter that you're making. Same thing with the rocks. The little bits and pieces of rock are automatically older than the rocks that they're found in. So here's an example from week 4. You had a picture like this, and you had to put it in order from oldest to youngest. So the black line is a fault where the rocks have shifted. It's basically where an earthquake occurred, and so these are no longer aligned. Really, this F went straight from here all the way to here, but we can't tell because there was an earthquake. Same thing, this yellow layer also used to be one giant layer, but the fault occurred after it, and so therefore it is now a little bit shifted around. So F is an intrusion where that magma rose up and eroded or dissolved the layers of rock, and it cut through it, and therefore it's a law of cross-cutting relationships. It is younger than anything that it cuts through. So you want to start at the bottom and work your way up. So J is going to be your absolute oldest. You can tell that because all the other layers are stacked on top of it. Yes, these layers are diagonal, but remember that these layers were originally laid down horizontally, which means that J would be your bottom layer. H would form on top of that, I would form on top of that, and then B, and then E. And then F is a cross-cutting layer that cuts through H, I, B, and E. So this little part here indicates that it also cuts through E. It did not cut through layer D, so that means that F is actually older than layer D, because otherwise it would have cut all the way through this one as well. So the order is J, H, I, B, E, F, and then D, C, G, A. So D, C, G, and A do not have layer F in them at all, so that's how you know that they are younger than layer F. Okay? This is another example from week 4. This one, we asked you a series of questions about it. We did not have you put it in order because actually this is in alphabetical order. So again, there is a fault here in which the rocks shifted. So layer F got moved and split apart. So did layer G, so did layer E, D, C, etc. So all of these rocks shifted along this fault line because of an earthquake. M and R are both intrusions. This was magma that came up. That's why it has the red around it, because it's hot. It dissolved or eroded those layers. And then R is another cross-cutting layer that also dissolved or melted, however you want to think about it, dissolved the layers that it cuts across as well. You can also tell that layer M is going to be younger than all of these layers, so A through L, because it cuts through all of them. And then layer R actually cuts across layer M. So R is actually younger than M, and it cuts all the way into layer Q. So the order goes A, B, C, D, E, F, then G, that fault that shifted all of the rocks. Oh, sorry. Then G is this blue layer. I is these little inclusions here. J is this layer here. And you can tell that H comes before J because that fault did not cut into layer J. So A, B, C, D, E, F, G, H, and then I, and then J, K, L, M, which is your intrusion, that cross-cutting layer. M, N, O, that's these guys. P, Q, and then R cuts through all of those, and then S, and then T. So that's how these work out. You just start from the bottom, work your way up, and then you really want to be mindful about where these intrusions begin and end. Yes, they start from the very bottom, but they are not layers because they are not laid down horizontally. These, you can tell, are actually intrusions. They intruded into the rock, okay? This one was your challenge from week 3. And this one, you can tell that which layers go together. Again, this one has a fault here, but the fossils actually give you good indications of which layers go together. So for this one, layer I is going to be the bottom layer, and then layers G and L go together because they have the same shape of fossil, that diamond fossil. F and K go together because they have those circle fossils. E and J go together because they have the hourglass fossils. And then D comes after that. There was the fault that comes next because those rocks shifted, and then layers A and C both got laid down horizontally after that. Remember, law of original horizontality. And then lastly, H is an intrusion that cuts all the way through all of those layers. So it is younger than all those layers because those layers had to be there for it to cut through. And then lastly, B came before that. And you can tell because B actually cuts across that intrusion. So you know that B is actually the youngest thing out of all of them. So the order was I, J, L, because these two are made at the same time, so you list them in alphabetical order. F, K, E, J, D, C, A, H, this intrusion, and then B was the last one. Okay, so if you don't understand and you still have questions about it, that's fine. Join me on office hours and we can talk about it. And that is your video for the stratigraphy layers. And I hope that that helps.